1106. Comparing Z-scores. So, since Z-scores do not depend on the value of the mean, we use them to compare scores from different normal distributions. Just because you got a higher percentage in one subject doesn't mean that you perform better than another subject. Okay, this is what this exercise is all about. So, here are Jude's marks for her half-yearly exams along with the class mean, which is the class average, and the standard deviation for each subject. I mean, look at art. It has the highest mean, right? So, but even though she's got the highest mark in art, her art mark, look, it's below the mean. Her science mark is below the mean. Her maths mark is above the mean. And her English mark is below the mean. I can already see what her best performance is. Can you? Which one? It's maths, because she's above the mean. In every other subject, she is below the mean. Or he, Jude. Girl? Guy? I don't know. Her. Her. Yes. Judy. I'm going to calculate her Z-score for each subject. So I'm actually going to use the formula unless we want to draw all different graphs. I really don't want to draw 4 different graphs. I'm going to do her Z-score for each subject. So let's go. We've got English. Remember, the Z-score is the mark minus the average over the standard deviation. So for her English Z-score is 65, take away 75 over 14. I know it's somewhere between 0 and -1. Just by looking at it, the standard deviation is 14. So she is within one standard deviation on the negative side, but we should get negative point something here. It's 10 over 14, which is negative 0.71. Oh, yeah, okay. Yeah. Negative 0.7, I don't know why I've got all these points. Negative 0.71 will do. Negative 0.71 will do. Don't worry about the rest. Just go ... Next one, maths. She should have a positive Z-score for this because she's above the mean. X minus X bar over S over the standard deviation. 72 minus 65 over 10. Isn't that 7 over 10, which is 0.7? That's positive. That's a positive Z-score. Science. Now, you won't be asked to compare 4, okay? You may be asked to compare 4 by just looking at it and saying in which one did she perform better. We knew that science was the best because it was the only one with a positive Z-score, all right? All the others have a negative Z-score. So, you know what? She can't say art is her best mark because it's her highest mark, but it's not her best performance because she's below the average. So, science has a Z-score of 58 minus 62 over 16, which is, what's that, negative 4 on 16, negative 0.25. So which one's better, English or science? No. Oh, yes, English is, sorry, it is, I'm sorry, it is. And art, the Z-score is X minus X bar or mean over standard deviation. 78 minus 85 over 8. That's negative 7/8, which is what? Negative 0.875. Okay.
English one is wrong.
Oh, did I make a mistake? Yes. Oh, sorry, ladies. I made a mistake. That's negative 0.714. All right, yes. Negative 0.714, etc. So, answer to part A, find Jude's scores. We've done that. And part B, rank her subjects in order of her performance. Now, her best performance is maths, number 1. So, maths is the best. And then, all right, think of a number line. See, look, 0.7 is the highest. What's the next smallest number? The next. Negative 0.25 is next. I'm just ranking these. If you're on a number line going down, wouldn't you pass 0.7, negative 0.7 before you passed negative 0.875? Look, watching. Here is 0. Here is negative 1 on the number line, and 1's over there. Negative you know, this is negative 0.5, negative 0.6, negative 0.7, negative 0.8, negative 0.9. So this is the order. Negative 0.25 would be there. Negative 0.7 is next, and negative 0.8 would be closer to. So it goes. Yeah. So you have to look at a number line. Negative 0.1. Watching. Wait. Look, I'm going to do it up here. 0. Negative 1. 1. Up here. Isn't that negative 0.5? This is negative 0.1, negative 0.2, negative 0.3, negative 0.4, negative 0.5, negative 0.6, negative 0.7, negative 0.8, negative 0.9. That's negative 0.9, negative 0.8, negative 0.7. Do you get it? So, where is 0.7? It's up here. That's 0.7. This is, what marks that? 0.7. That's maths. Up here. Where is, oh sorry, no, maths is positive 0.7. English is negative 0.7, which is here. English. Sorry.
So you do better in the subjects that people do worse?
You do, you can only compare Z scores, not percentages. Negative 0.25 is about here, so that's science. And negative 0.875 is about here. That's art. Okay? So I've put those numbers from 0.7, which would be about here, negative 0.25 is there, negative 0.71 whatever is about there, and negative 0.875 is about there. So we can see what she's done best in. If you've got a positive, the more positive your Z score is, the better your performance. So the best performance is maths. Do you see? You've got to go from the highest number and work down. So the highest number is 0.7. The second highest number is negative 0.25. The third highest number is English. And the lowest of all these numbers of the Z scores is negative 0.875. So her performance is maths, then science, then English, and then art. And you know what I would do? I'd put that this is the best performance and that is the poorest performance. Yes, that's right. It's got nothing. But look what the average. People did really well in this test.
But she still did better.
Question 5 here. Okay, annual rainfall figures are normally distributed in downtown. The annual rainfall distribution has a mean of 950 and a standard deviation. So that's your mean, and a standard deviation of 420. Now I'm just going to draw this so we get an idea, okay? So now we need to add 420. Oh, we're going to end up with a negative. You can't have negative rainfall, so it's a bit weird. So 950 and a standard deviation of 420. So what's 420 added onto that? 1370. Add 420, 1790. Add 420, 2210. Subtract 420, we get 530. Subtract 110. This is negative. Now, you can't have negative rainfall. I'm just going to circle that one. You can't have negative rainfall. All right? But that's just how the figures turned out. All right? Now, in Uptown, however, the mean annual rainfall is 1,325. And the standard deviation for that town, so what's this one? Downtown? Downtown. And this is uptown. So downtown and uptown. So you know what? We actually don't need to do this. We could just work out the Z score for each place. But look, we're going to visualize it. But we don't need to do all this. If you add 238 to this, what do you get? Whatever. Let's just subtract. Can we just do -1, -2, -3? 1, 2, 3. Has anyone added on the 238s? All right, etc. And can we subtract 238? 1325. Oh, God. I don't really need to do this. but we're just showing what it means. In downtown, see how weird this is? I mean, negative 320 millimeters. That's like, it didn't rain and the water was evaporated from the lakes or something, you know, whatever.
Yeah.
But look, that doesn't make sense. But it says which town is more likely to have an annual rainfall of 1,100 millimeters. Now, 1,100 is here for, you see, 1,100 is there for uptown, and 1,100 is about here. That's approximately where 1,100 is. So 1,100 is just above the mean for downtown, and 1,100 is just below, well, it's nearly one standard deviation. Oh,
No,
yeah, it's just above -1. But let me just work out, I know that's by drawing, but let's work out the Z scores for each.
So that can't be a justification.
No,
Wait, what can't be?
wait, we're going to do the Z scores for each. Let's just work out the Z score of each. The first town, look, I know I didn't really need to do that, but I'm doing that to visualize, all right? So downtown, the Z score is X, which is minus X bar over standard deviation, which is, what's the score? 1,100 minus the mean is 950 over the standard deviation is 420. And what did we get? 0.3 something, right? Anyone, guys? And uptown,
Negative 0.945.
uptown, it's 1,100 minus 1325 over
238.
238, and the Z score for uptown is
Negative 0.9.
negative 0.9, 0.9,
Yeah,
Now,
0.945.
etc. for whatever. Now, this first one, downtown has a positive Z score, uptown has a negative Z score, but downtown is also closer to the mean as well. Now, I'd be putting both. I'll show you why. I'm going to draw, you know, this graph. You know, remember the whole graph thing? Really, there are imaginary histograms underneath each. Now, here is 0, and there's 1, and there's 2, and there's 3. Do you remember the first diagrams that we looked at looked like this? Do you remember that? Right?
Yeah.
Now, if you're sitting in here, it is 68% of the scores. But if you're sitting at 0.357, remember that's really just a column in there that's that high, right? Do you see that? And if you're looking at negative 0.945, you've got a column here, but it's not as high. Do you get it? These are really histogram graphs, like it's a histogram. What you've got under that bell-shaped curve are columns. Now, the column for 0.345, for 0.357 is higher. Do you remember how we had that curve and there are imaginary histograms underneath? The column of 0.35 at a Z score of 0.357 would be higher because it's a bell-shaped curve, whereas this column of negative 0.945 is near -1, and that height of that column is lower. So it's not just about the higher Z score. I think it's also got to do with how close those Z scores are to the mean, because the mean is the highest column in that histogram. So downtown has the Z score closest to the mean. Closest to the mean. And you can also put in brackets, it also has the highest Z score. Remember, Z score's got to do with performance compared to the mean. So being a higher Z score, one sec. 2007 HSC question 25D. The results of two class tests are normally distributed. The means and standard deviations of the tests are displayed in this table. Let's just have a quick look. The mean for test 1 is 60. The standard deviation is 6.2. The mean for test 2 is 58. Standard deviation is 60. Now, it says Stuart scored 63 in test 1 and test 2. He thinks he performed better in test 1. Do you agree?
No.
I can already tell he didn't, because in test 2 he's higher. but we've got to look at the standard deviation. You know what you do? You just do the z-scores for each.
You say like the lower the deviation, the better.
It's your performance compared to the average. You need to do the z-scores for test 1 and 2. So test 1, they're going to be similar, but one z-score will be better than the other. So test 1 z-score is x minus x bar over standard deviation. So the score is 63. The mean for test 1 is 60, and the standard deviation is 6.2. Has anyone worked out that? 0.48 will do. Right, test 2, x minus x bar over standard deviation. It's 63 minus 58. Can you see he's already 5 marks higher? But you do have to take into account the standard deviation as well. It's not just how much higher. We need to know the standard deviation too. Now, I think this is going to be slightly higher. 0.6 recurring, which is 0.666, etc. So, he has performed better in which test? The one... No, the higher z-score is the better performance. So therefore he has performed better. So therefore he has performed better in test 2 because it has the higher z-score. So performed better in test 2 as it has the higher z-score. Only by 1 point something, but you just need to say the z-score is higher in test 2. His performance is better in test 2, even though he got the same mark. Better performance. Look, the mean, the average for test 1 was higher, and the average for test 2 was lower. So he's done better than, a lot better than the average, like better. He's 5 marks above the average in test 2, only 3 marks above the average in test 1. But you also have to look at the standard deviation as well. You can't just look at how high above the average. We need to know what the standard deviation as well is, but the standard deviations are very close. So, all right, now in part 2 it says, if 150 students sat for test 2, how many would you expect to have scored less than 64? So you can just do your, I would just do my graph. Test 2, average is 58. Add on your standard deviation, what do you get? Plus 6 is 64. There's your number. You don't even need the rest now. And then you can go down if you want.
So it's like that 47.5.
So if we want less than 64, it's down there. 46, 40. So wait, be careful with this one.
So for the first one, you put 63 minus 58, it's 62 minus 58.
Oh, no. Oh, sorry, 62 in test 2. I'm sorry. Test 2 is 62. So what does this equal? Sorry. Oh, it is. It's 0.6 recurring. Yep, just didn't read it properly. And 62 in test 2. Sorry.
Isn't it just 50%? And so if it's 75 students, I've got below 64.
150 students sitting for the test. How many students would you expect to have scored less than 64? So, girls, I'm going to break this up. From 0 down, isn't that half the graph when the arrow goes all the way down? Yes or no? I need all of this. This bit here is half the graph. From 0 with an arrow all the way to the end, that's 50%. But what about from 0 to 1? What's 0 to 1?
34.
It's half of 68, remember? Remember we have negative 1 to 1 is 68%. So from negative 1 to 0 is 34%. And we know that from 0 downwards is half the graph. When the arrow goes there all the way down, non-stop, past 3 standard deviations, it's 50%. That bit's 34%. So it's 50 plus 34 is 84% of the students. Now, how many kids are there? Do we get it? How many kids?
It was 126 and I said 120.
84% of 150
Equals 126 kids.
is 126 students. Deviation is replaced with population standard deviation. In other words, you use this button on your calculator, sigma x. Ali's class sit 2 geography tests The results on her class on the first geography test are shown. The mean is 68.5. We have to calculate the standard deviation. So you need to go into your calculator in data mode. So data mode, and you've got to go 58M plus, whatever, 74M plus. Enter all your data. Statistics mode. You need to go into stats mode, SD.
And then what do you do?
Can I see? So then you go 58, enter your data. 74, enter your data. It should say N is 1, N is 2, or data set 1, data set 2. Anyone doing it?
Yeah, got it.
Keep going. You should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, you know how they tell you the mean 68.5? That's really good, because when you do put this data in, you can calculate the mean and standard deviation. To know that your data is correct, I would calculate the mean on my calculator as well. So has anyone put those all in?
What do you do after you do 70?
Did you press M plus? So now
68.5.
you do X bar. You have to find X bar and you should get 68.5. And standard deviation is this one, which is, anyone got the standard deviation? 5.22.
Put the numbers in order.
They want it to one decimal place, 5.2.
Miss, how do you get that?
If you can sort of tell if you've missed a number by looking up how many bits of data in your
How do you get the data?
second geography test. The mean is 74.4 and the standard deviation is 12.4. Ali scored 62 on the first test. Calculate the mark that she needs to obtain in the second test to ensure that her performance relative to the class was maintained. All right, she scored 62 on the first test. Let's work out her Z score for test 1. So her Z score for test 1 is X minus X bar over the standard deviation. So what do I do for test 1? 62 minus what? No. Test 1.
Oh, 61. Oh, 68.
68.5 over 5.2. So her Z score for the first test, we need to work that out.
Negative 1.25.
Yeah, and we know it's negative because she is below the average, negative 1.25. Now, she wants to maintain that test, that Z score in test 2. So the Z score in test 2, she wants to also get negative 1.25, right? So let's do test 2 to see what mark she needs to get to maintain that Z score. So we go Z is X minus X bar over S. The Z score is negative 1.25. The exam mark we don't know. Do we know the mean for test 2? It's 74.4. And the standard deviation for test 2 is 12.4. And so now we do negative 1.25 times 12.4 is X minus 74.4. Anyone got something there? So now we're solving for X.
Negative 15.5.
Equals X minus 74.4. So how do we work out X? We add. So we go negative 15.5 plus 74.4. So she needs to get a mark of approximately 59. So she needs to get a mark of 59. All right? In that second test to maintain that performance. So a mark of 59 should be negative 1.25 as well. Okay? Good question.